Hello there, welcome back. We're going to keep moving forward. We're going to do some more synthetic division, and I'm going to introduce the formal remainder theorem definition. So you're going to see a phrase called synthetic substitution, and we're going to define what that is, and then we're going to use the remainder theorem to help us find function values or to evaluate, okay? All right. So synthetic substitution is a term you're going to see, but it's nothing more than synthetic division used to evaluate a function or finding the function height. Okay, the main difference is that you're going to be presented with something that looks like find f of 2. Now, had we been given the factor x minus 2, we would have known to flip the sign on the 2. However, now they're presenting it to us and they've already done the flipping, so we are not going to flip. We are not going to flip, all right? And just as when we were we found the function height before, here's the formal definition. So if you have a polynomial f of x, and you use you're dividing by a polynomial, say x minus a, okay, the remainder is going to be f of a, which is the same as saying the remainder is the function height. You can say it's the height of the graph. You can say it's the y value. Those all say the same thing. Okay? So let's use synthetic substitution, which is nothing more than synthetic division using this as our divisor. So we have a 4, and just like we did before, we have to check for missing signs. So I have 3x to the 4th, and then I have negative 2x cubed. And look, I don't have an x squared, so I'm going to put in a 0. And then I have 5x, and then I have a 2. I'm going to bring down my 3. 4 times 3 is 12. 12 minus 2 is 10. 10 times 4 is 40. 40 plus 2 is 40. 4 times 40 is 160. 160 plus 5 is 165. 4 times 165 is 660. And I add 2, and I get 662. So here's my last term. This is my remainder, just like before. Okay? So that says that f of 4 is equal to 662. So that means that if I plug a 4 in, I should come up with 662. So let's try it. So I have 3 times 4 to the 4th minus 2 times 4 cubed plus 5 times 4 plus 2. So this is 768 minus 128 plus 20, 20 plus 2 gives us 662. Same thing, it's the function height, okay? Honestly, sometimes it's faster to do it this way, sometimes it's faster to do it with synthetic substitution, but we just need to learn what synthetic substitution is and how to use it and what it means. Okay, so on this next slide, I want you to, this will be the problem in the video question. Go ahead and answer, find the value of f of negative 3 and come back and check your work. All right, my divisor is negative 3. They've already done the flipping for me. I need to make sure that I have all terms presented. 3, negative 6, 1, negative 11. Yep, they're all there. I'm going to bring down the 3. 3 times negative 3 is negative 9. Add, that's negative 15. Multiply, that's 45. Add, that's 46. Multiply, that's negative 138. Add, and I get negative 149. So f of negative 3 is equal to negative 149. That's the height of the graph. So if you go out 3 units, or 3 units to the left, you're going to go down 149 units below the x-axis. All right, go ahead and try this one. This is your next video question and see what you get. Remember to look for missing terms and plug in a 0 coefficient. All right, my divisor is 6. I don't have to flip it. Let me look and see if I'm missing anything. I have x to the 4th, and then I skip to x squared, so I have to put in a 0. And then I have an x squared, so that's a -5. And then I have an x, and then I have a -7. All right, so here we go. I'm going to bring my 2 down. 2 times 6 is 12. 12 plus 0 is 12. 12 times 6 is 72. 72 minus 5 is 67. (67) times 6 is 402. And I add 8 and I get 410. 410 times 6 is 240, or 2460, and I subtract 7 or add -7 and I get 2453. So f of 6 is equal to 2453. And it's that simple. That's using the remainder theorem and synthetic substitution. So in class, we're going to be working on these problems. Notice that I have some special instructions here. So for number 1 and